I've just started looking for.
Oh.
Why did you leave the new dashboard to return to Classic?
I'm like getting pre-approved and all that
It was
stuff.
too hard to manage my current or upcoming students. Yeah, that thing was terrible.
And then my
I like how it immediately pops up when I go back to the old one, and I'm like,
hoping that it won't be an issue.
okay, I think we're actually going live. Yeah, like what the hell? Okay. I still technically need to go grab my tripod, but for your talk at least, you want it on view or you want it on
They're
the...
like
Wherever. I have a tendency to wander around, so
Okay. It's
my parents are like my
just to be a troll right now.
let's stay.
Yeah, let's see when it moves where it goes. Okay, good enough. I'm gonna get a tripod.
Yeah, you are.
And I'm gonna open the meeting so that you can do your talk on leadership. Yes.
Yes, I'll bring it back.
Alrighty. We're gonna go ahead and get started. We have a lightning talk for a change because thank you.
Yes.
So leadership, turning followers into leaders for the submarine.
Yeah.
All right, we're gonna go ahead and get started. So stop having fun.
So, good evening, everybody. My name is Louis Reichenbach. I will dive into a quick introduction, which I don't have a slide for, and then I will talk about a little bit of why this is useful for .NET developers, or any developers, or really any employee. But and then we'll get into the meat of it. And I will try to hurry so that we can get through to the big talk, because I'm excited to hear about the COBOL. So, my name is Louis Reichenbach. I am a .NET full stack developer. I have been writing code since I was like 11 or 12 years old. I started with BASIC on a TI-99-4A. I wrote code at magazines. I joined the Air Force and did some radar stuff for a bunch of years, and then went back and got too many degrees in all kinds of software engineering. I did Visual Basic, Power Builder, .NET, through 20 years worth of stuff. I did 6 years as a professor for game software development, where I taught C++, game engines, all kinds of stuff. I was even the program director of like 300 students. It was a pretty cool gig. I miss teaching, which is why I'm up here talking, because this is how I get my fix. So thank you for indulging me, and we'll talk about this. I have found, hopefully you guys are all going to shake your heads, I have found that developers in general do not have very good management and leadership skills. So that's the part where you shake your head. There's probably only a few people that are really, really good at that, and it's really a bummer that that's the case. So what happened was, I was at a job and the director introduced me to this guy I'm going to introduce you to. His name is David Marquet. He was a captain of a sub, not this one. This one's from World War II. I took that picture, by the way, humble brag, and move on. He came across this really cool situation, and after I read the book and started following his stuff and getting his weekly nudges, he calls them, I have found that we can all become leaders. The best part about this is you do not have to actually be a manager to be a leader. Those are different things. If you are a manager, you're planning and scheduling and organizing. If you are a leader, you're showing other people how to be more effective, to motivate them, to provide vision. These are the kinds of things that will, and this is the point of the whole talk, they're useful for followers and leaders. And actually, we're going to get to, you should just be a leader, whatever position you're in. So that's how this is useful for developers. So let's dive right in here. First, let me tell you the story about this captain. So he is an up-and-coming naval officer. He's going to be the best of the best. The Navy is like just running him through all of the training and all the stuff to be the best captain of a nuclear submarine that they can have. He's just the shiniest star. So he graduates from sub school and he's ready to go on his mission, but then this guy retires from basically the McHale's Navy version of subs. The sub is just horribly maintained. The people are on board are terrible. They can barely keep themselves straight. Nobody gets promoted. People are leaving left and right, and so they figure this shining star can go out and make things right. So what happens is he gets onto this new sub. It's not a nuclear sub, it's 1,000,000 years old. So he doesn't know where all the buttons and switches are. He hasn't got the foggiest idea, and he's starting to kind of rummage around in his head that something's not right when this happens. He says, and you can picture this from like a movie, right? He looks over at the guy next to him, his second in command, and he says, ahead 2/3, or down 2/3 or something. He gives some sort of order, and the XO yells it out, ahead 2/3, and then everywhere down the line, ahead 2/3. You know, it's the military. Everybody's going to go ahead 2/3. And then 3 seconds later, the captain's like, why aren't we moving? What's going on? And so finally, the guy down here, who is just like, he doesn't even have stripes. He's brand new. He pushes a button that says ahead 2/3. There's no ahead 2/3 button, the XO informs him. It doesn't have that setting. It has half, it has 3/4, it has everything but 2/3. It's like, oh, we're not going to get anywhere with this. So he thinks it through, and he suddenly realizes, I am not the person that's supposed to be leading this thing. I do not have the information. I do not have the skills to do this. I have no control over this whole situation. So he goes back to his admiral and he says, we're going to do something different. Now you got to imagine, if you're going to do something different in the Navy or in any service, you're going to cause quite a ruckus because they're so used to this, this form, this structure, right? The thing to keep in mind about this is how we normally see our lives as developers. The manager or leader is in charge and he tells us what to do and then we go do it. But we all know, we're all sitting there right now thinking, that's not how it works. There's some manager up there that's telling me to like unkink my cables because the ones are going to get stuck, right? This is not how this should work. What should be happening is that we should be moving this stuff up. So here's how this is going to work. This is what I'm going to cover real quick. And again, I'm going to trying to rush through this, but we're going to talk. We've kind of talked about the overview. We're going to talk about why this is a good idea, and I'm going to tell you about these 3 pillars. So, if you are a leader follower, you are looking for this, and I guarantee you this is your day right now. You're doing quick bug fixes. Nobody's leading. Everybody's just kind of running around. Everybody's just following orders. It's all about obedience, right? Well, do the project on time, get your code checked in, all this stuff. What we're looking for is improvements that last. We're looking for everybody to lead, everybody to show the way. We're going to get to success with this. And here's how we're going to do it. Or here's why we need to do it. This is the percentage of respondents in this survey from down here that are dissatisfied. These are horrible numbers. And I know that these are not surprising numbers. 63%, 77%. People that are not motivated is almost that 2/3 number again. If you do not have motivated employees, you're in trouble. So, we're looking for empowerment. I like the word engagement here too. Those two kind of go hand in hand. We're going to get higher performing employees out of this. If you're a leader and you're bubbling up this information and these tasks, and we'll see that in a second, you're going to get better performance. Less bugs, more stuff on time, the features that actually work the way that you say they're going to. Everybody's going to share in the success. Picture this sub again, right? And when everybody starts to improve, it's not just the guy at the station down there doing his task, the whole sub improved. The story that he tells in his book, that when that sub came back to base, they had won all kinds of awards, they were recognized by the Navy as a top performer and so on. That would be cool if we could do that with our teams. And then finally, the whole organizational performance. If you're doing a better job deploying your product, then more customers want it, more people are going to want to pay for it, you're going to get more bids for more offers, and so on and so on and so on. So for the actual managers in the group, we're starting here and moving up in terms of our what we're going for. So if you picture back to the first, if you imagine back to the first picture, one of the columns, one of the pillars was this pillar of control. And the big key in all of this is this I intend to. So if you imagine a scenario where you're talking to your leader and he gives you some tasks and off you go to go do them, hopefully he's leaving you to your own devices to find out the best way to do that. That may not be the case. What really should be happening is I intend to. So I need this project done on time. Okay, I intend to develop it this way. I intend to use these techniques. I intend to. Not the word plan. Plans fall apart. I intend to. So when you say I intend to, you are getting rid of this top-down scrutinizing. What should be happening is you are telling them I am capable of doing this. I'm going to take control. This is how you are going to become a leader, even though you're not necessarily a leader. But before you do that, are you capable of doing that? Do you have the technical competence, the skill to do it? Well, I intend to build a nuclear sub. No, I can't. I can't do that. But maybe I might be able to make a new class to like output some Excel spreadsheets. That I could do. So make sure that the people that are saying I intend to, the ones at the bottom, have the competence. So if you are at the bottom, you need to make sure that when you say I intend to, that you are able to keep your promise. If you are the manager or leader, you need to make sure that you are training your people so that they have that competence. If they do not, it is not necessarily on them to go get it. You need to work as a team to build that competence. If you're expecting people to say I intend to, then you need to be able to give this to them. So here's some points about that I just literally covered. Always be learning. Swap out instructions for certifying. Again, if somebody's saying I intend to, then you're certifying that that's true, that they can actually get that done. Now this goes hand in hand with clarity. That's the word that David Marquet used. You can think of it as just information. If you say that you intend to complete the project, do you know why you're doing that? Do you have any idea what the vision is going to be? The reason that I'm asking this question is because we've all seen the funny picture on the internet where they try to build a tire swing and it comes out all wonky, all over the place. There's a tree missing, there's all kinds of stuff. If you don't have that clarity about what the goals and the vision are, you can't get it done. So those three things together, the control and the competence and the clarity, allow you to say intend to and get away with it. And again, this is not something that's done in a vacuum. The team together has to work on this. So if you don't have that information, then the leader has to provide that to you. And that way you can make sure that you get your stuff done. This allows you to strive for excellence instead of reducing errors. Because we've all been through this as developers. We sit around and all we do is fix bugs. Why are we fixing bugs? Probably because we either weren't competent, or more likely we didn't know. They're not usually bugs. We're not bad programmers. What ended up happening was the customer said, well, no, I meant no negative numbers. Oh crap, if only you told me that. So that information has to come down to the bottom. I'll steal a thing from Covey, begin with the goal in mind. If you've not read Covey, it's kind of interesting to deal with it, but there's start with that goal in mind. Again, this is how you're going to build that information up. So, I tried to do that as quick as possible, and I know I glossed over a million things, but this is a new way to think about leadership. You are a leader. You're going to say I intend to. You're going to make sure that you have that competence and clarity to take control. And the reason we're doing all this is we're going to become better performers. We're going to work better in teams. This will give us the ability to start at the bottom and lift our way up, which gives us empowerment and engagement. And all of these things will lead to better performance. Now, I forgot to grab my visual aid, but I have the book here with me. It's called Turn the Ship Around. It's by David Marquet. It's a super fun read. Of course, I was in the military, so I have a little bit of extra interest in that sort of thing. But it goes through this storytelling of how he took his McHale's Navy ship and turned it into one of the best in the fleets. And now the guy travels the world making millions of dollars, giving probably what I just, the same exact speech. So take a look at that website, Google his name and look into it, and then you can transform into your own kind of leader. I did this for school too, so I have a bunch of references. I'm actually trying to get my MBA as well because I'm an idiot. I just cannot stay away from school. How many more degrees do I need? Questions, comments, anything like that. And then before you guys fire off, I also wanted one more plug for myself. My LinkedIn site, you can type in my giant, huge, obnoxious name and go find me on the internet. Yeah.
Yeah, this is a very excellent subject, extremely important. I think this group would do well to sign you up with somebody to do an hour-long presentation of the subject.
I would love to. That's actually great. That's awesome feedback. I would absolutely love to. I am a good programmer. I am not great. A couple months ago when that guy came in here and he was talking about the pipes and all that stuff, a lot of that went flying over my head. I don't know about you guys, but some of it was gone. This is my specialty. I've been working on this for a long, long time, so I appreciate that. That's good. I'll love to do something. I'll talk to the gang about
and the organization that could do what you just talked about, what fell in the details of the longer presentation, will just soar right past the competition.
That's the hope.
Also, the people working in this kind of environment that you described will have an amazingly higher level of morale.
For sure, absolutely. That's absolutely right. I think that, and in fact, I'll tell you my own personal story. I work in the same department as you guys. My boss doesn't know what he's doing half the time. He's giving direction instead of asking how we're going to do things. I try to tell him I intend, and then he goes nuts. So I keep trying, and at the end of the day, it still makes me feel better. Makes me feel like I'm contributing a little bit more because every once in a while it works. He's like, "Oh yeah, you did think of all of that stuff." I'm like, yeah, I didn't. I made sure I had some competence and clarity before I came and talked to you. It's lost, but as you can see, it's certainly useful. Anything else? Good feedback.
What was called what?
Turn the ship around. I'll pop it out of my I go Google it real quick, but I don't think I'm even connected. But yeah, it's called Turn the Ship Around. In fact, actually, let's see if I can do this. There, it's this one. A true story of turning followers into leaders. If you go to his website, there's a really cool 4-minute video too about this that'll give you another high-level kind of approach to it. He's got a whole system about working your way up the ladder, where most employees are at the bottom. You just get fed stuff. We know the joke about the mushroom in the corner, right? It's dark, people pile shit on you, that kind of thing. So that's the bottom rung of the ladder. Up at the top is somebody that has earned that trust because of the competence and clarity by working as a team. And like you said, morale is high, engagement's high, and off they go. And there's all kinds of tips and tricks. He has weekly nudges, he calls them, where, in fact, today he was just talking about this exact topic again. How to listen to your employees, empathy, all kinds of things. It's really good stuff. Anything else? Well, thank you guys for hearing me out and letting me get my fix. Yeah, I'd love to do more. If you guys have other topics about leadership, career development, all of those things, I will absolutely put C#.net development spins on them. Like I said, I've been doing this a really, really, really long time, and I would love to share. So, thanks. Two Navy people in one day, right? You're talking about the Admiral?
Hmm?
You're talking about the Admiral?
That was such a good lead. Think about it, considering.
Yeah, I had that.
All right, plug in. So the way I have it set up is just that camera, which is also the mic. Okay. Normally we do pass-throughs and capture cards and stuff, but I'm feeling exceptionally lazy today.
Well, and my luck with the pass-through with the capture card.
Yeah,
I'm pretty sure Dustin told you. I think I finally figured out the ski one, you know, with all the power blips and everything. They tried the whole thing.
Oh shit.
Yeah, that has never worked again.
Well, that's not good. So let's get you plugged in, make sure you work.
That would be good.
Now I am buzzing. Yeah, let's put it this way. I haven't seen you in so long. That laptop was new when last time you were here.
Yeah, and it's feeling really good. This cable.
No, HDMI, right here. Where? Yeah, mine's 4 years now. Like, I'm honestly contemplating upgrading. But I also love my laptop, you know what I mean? And the new MacBooks have such terrible keyboards.
Yeah,
They're just, I don't, like, I would want to get a MacBook, but guess what? The keyboard sucks, so I'm not going to get a MacBook.
I'm actually putting Linux on my older one that has the mouse that I prefer.
I really like my laptop. It was just, I was trying to like build something and it was so slow that I ended up remoting it on my home machine. And in the time it took me to like fail to build, I was able to load up the files, load up the things, press the button, wait, and my home computer had it like done and dusted. And I was like, it might be time.
Yeah.
All right. So, in case anybody missed it, and as kind of a teaser, so I've been having way too much fun with my 3D printer. So I brought what is effectively some swag. So I have very dangerous, very pointy batarangs for you to throw at your coworkers tomorrow. I guess we'll just throw these in the raffle. And then also because it didn't work for me, and that's why you guys get my hand-me-downs. Right, so it's actually a headphone stand that I 3D printed, and it's actually great, except for the fact that my headphones are too tall. So, hi, we have unique swag. Next month I'll have a giant Pikachu or something. You good?
Yeah, I'm good.
Okay, ex-president on COBOL.
I know. It's Dustin's fault, remember? It's Dustin's fault.
Dustin!
So my name's Ken. I don't have an intro slide either. Background's actually not too much different than Lewis's. My first coding was on a original first generation Coco. The neighbor kid got back in 1979 or 80. I started on my first was a VIC-20 and learned through coding in the magazines and learning you didn't have Google, you didn't have a user group to go to, you actually just beat yourself up until you made the code work. So I've been developing professionally almost 25 years. Last 15 with the Internal Revenue Service. Yeah, it's a job. They pay. They pay sometimes. I'm actually employed now. The first 2 times I gave this, I technically was unemployed. Most of my work has actually been modernization of legacy systems. And by legacy, I mean stuff that we have users that used it their entire life and retired and came back 10 years later and said, wow, it's still running. Our definition of legacy is a little different than others. I've done COBOL to Java complete replacement, COBOL to .NET complete replacement, COBOL to ETL tools complete replacement, and hybrid, trying to leverage what we can reuse out of COBOL. And the more I've been doing it, the more I've looked and thought, you know, we missed out on some of our history. And there's some things I look back, some of the cool things that we're doing today, and I look at what is already in place on the mainframe, and I go, you know, this isn't as new and exciting as we seem to think it is. And it's kind of realized that the history lesson wouldn't really hurt us too bad. So the obligatory Abe Lincoln slide. So I've got a little bit of random trivia in here as well. First bit, a lot of people think that this came from Winston Churchill. Some people say no, Winston actually stole it from someone earlier in the 1900s. This actually, this version of the quote is actually from the 1700s. So at least 200 years earlier than most people think, because we didn't learn our history, so we just keep saying. So, I said I've been doing this about 25 years. And so when I first started in the industry, yeah, in the early 1990s, there was a recession. A lot of big companies cut their IT staff in half, had just enough people to keep the doors open, not much more. So then this whole idea that you could do client-server development kicked up, and IT shops really weren't paying attention, and I was basically in shadow IT. Marketing departments had money in their budget to pay us to develop, and we hid servers in the closets, in the broom closets, not the wiring closets. And we decided, you know, compared to getting your IT department to respond, servers were cheap. So everyone just got a server. We didn't care about enterprise standards and any of that kind of stuff, because we just get our own server. Everyone could get their own server. Things were great. Then we started putting servers on the internet, and we started getting security vulnerabilities. And one day, operations woke up and said, crap, I've got a data center the size of Vermont. And now I've got my Patch Tuesday every month, and it's taking me 6 weeks to do my monthly patching. We've got a problem here. Also, I've got 5,000 servers in there at 3% utilization. But we didn't code with any standards, and our code is so iffy at this point that I'm afraid to put this app and this app on the same server. So we'll create virtual machines. Yeah, that's it. Virtual machines will fix a problem. Reduced our real estate, improved our utilization a little bit, but we still got 5,000 virtual machine images to deal with. So we really didn't advance too far, but we've got these great ideas. We'll go to the cloud, which originally we called utility computing. And then somebody had to be cool and give it a better name. So then we didn't buy the equipment. We still have 5,000 server images we're managing. And so we were still kind of out there, not a lot of great standards. And then we reached this. Yes, 463 million lines on a bill for his AWS cloud account. Because we went to microservices, and containers, that's gonna fix our problems. And so this is great. We actually wrote our own billing engine just to figure out our AWS bill, because we're making progress here. So to give you a little different perspective and just kind of change how you think about things, it's what if microservices on containers is the epitome of our code is so poorly written that we're afraid to deploy 2 pieces of our own code on a single OS image, and then we're afraid to touch it once we do deploy it. Because we lost 40 years of computer science actually learning how to do things that work together. So here's the problems with my story. Utility computing, what we call the cloud now. Ross Perot kind of came up with that idea in 1959, made him a billionaire by 1971, taking money from other companies to run their programs on his data center. Chargebacks go back to the 1960s. It's actually built into the mainframe operating system to actually figure out which program gets charged to which project and which department pays for it. Don't have to go write a billing system and sort through 463 million lines of AWS billing. And hypervisor and virtual machines have actually been standard on mainframe since 1971 or so. So a lot of the stuff that we think was new and cool and hip and saved us in the server world existed before I was born. And the more I dug into the mainframe, the more I started running into these kind of situations that were recreating things, because when I got into IT and we're going to do client server, it was mainframe, that's going to go away. Y2K is going to kill that thing. We don't need to learn what they knew. We don't need to talk to them. So let's take a trip in the Wayback Machine. Got a couple people who actually know who this is. It's Mr. Peabody from the Rocky and Bullwinkle show.
And Sherman.
And Sherman, yes. Mr. Peabody's the important one. Sherman, no one cares about Sherman over there. It's Mr. Peabody. So, 1940s, Grace Hopper had a master's degree in math, was actually teaching at a university, and tried to join the Navy. Navy told her she's too old. Military, law enforcement all have age restrictions because they don't want 60-year-olds out there on the front lines trying to figure out how to lift a gun. So she joined the Navy Reserves. And just about that time, the military was trying to figure out how to speed up calculation of bomb trajectories. And IBM delivered a computer. Well, they didn't call it a computer. Computers were actually people who sat in rooms and manually did math and did calculations. They delivered something that'd be more akin to this. It was a bunch of components in a box, and you turned dials and ran wires to plug them together to build your own instruction set, basically. You know, if you took a wire from here and plugged it into there, and one over here, and then there, and then put an input in here, it would add two numbers together. That's actually computers, what we now think of as computers, in the 1940s. So this is actual video footage, if this decides to start playing. There's actual graphic video footage from the Harvard Mark I, which is where Grace Hopper went. And she's just off camera right now. If this video decides to start playing,
It started playing.
on screen, on here it says it's actually playing. Okay, well, but anyways, this is an actual archival footage. Grace Hopper is just off screen here. This is the computer. Little old footage shows them tweaking the wires, dials. And this here is rolls of paper. And you think, where did we come up with this idea of punching holes in paper? So this was kind of an interesting tidbit, which is not going to automatically forward now because it thinks the video is still playing.
Pianos, player.
No, predates the player piano.
Really?
Yeah, so the loom. So this is the punched paper that was how they were originally programmed. Each line is effectively one word. And we think of it kind of as being actual machine language now, but that combination of holes, the machine would read a line, go through its wires and circuits as it was keyed up, and execute a command, and then put forward the piece of paper, forget the last command, and read the next one. The idea of a program being stored in memory, the entire program in memory, didn't exist yet. Unfortunately, the video didn't play for whatever reason, but you actually had, on the Harvard, you had multiple rolls of paper, one for programming, you have others for data, which is now referred to as the Harvard architecture, the idea that you keep your program and your data separate, which prevents you from some of the buffer overflow exploits that we get on the Intel architecture. Because even though this existed for 25 years before Intel built their first integrated circuit, Intel didn't learn their lesson about architecture, and we're still living with that today. But on the left there is Mr. Jacquard. In 1804, he introduced the programmable weaving loom that used a series of pieces of punched paper woven together to program a weaving loom to make intricate designs. That is actually a picture of the Jacquard that he made of a self-portrait. This was only done on request. There wasn't like a stock of these in the store. You had to actually request one. One of these was actually in the possession of Charles Babbage, which then from Charles Babbage then made it into adding machines from NEC and IBM, or NCR and IBM, in the early 1900s. So it's an incredibly proven technology that was in use until the 1990s, because you don't experience bit rot from your disk with this. So into the 1990s, ROM chips were programmed from punched paper, because they could load up a bunch of chips, read the paper in, and be assured that as long as the paper didn't deteriorate, if you had good quality Mylar or something, you had no data integrity issues between runs. You also notice the holes are punched incredibly well. We figured out somewhere in the 1800s how to punch nice holes in paper without issues. Unless you're in Florida, which is great. In January when I gave this the first time, Florida had just gotten into the news again for not being able to punch holes in paper reliably. This picture is actually from the 2000 election that we all remember being so great. So again, we learned almost 200 years ago how to punch a hole in the paper cleanly, but we can't be bothered to learn that lesson again and apply it to an election. So this is from the late 40s. Most of you have seen this before, the first actual case of a bug. This is from the Harvard Mark I logs of the day they thought a tube blew and it was actually a moth stuck in the tubes. The tubes in the 1940s were so reliable that they spent more time figuring out which tube blew than they actually spent running programs. So there's two interesting things about this log. Notice this first actual case of a bug. A lot of people believe that this is where the debugging term came from. But it's not. Thomas Edison actually referred to working the bugs out of his designs in the 1880s. And that's why it's the first actual case of a bug, not the first bug. The other thing is there's timestamps down the side. This logbook was actually where they wrote down everything they learned. It could take them a week or two to actually set up all those wires and switches and dials to run a program. So they were actually taking notes of things like, literally, I plug this wire in here and turn this dial, and if you punch these 7 holes, it will add 2 numbers together, because it was that archaic. But everything about the first instruction set is actually in this logbook. But we overlook that. So there's so much more there than just this moth.
Documentation.
Documentation, lessons learned. Everything we don't do today was in that book, complete with timestamps. It's what I wouldn't give for a team that would do this today. So Grace left the Navy and went to work for the company that actually built the Harvard Mark I. And so in 1953, she wrote this article called Compiling Routines. It was published in Computers and Automation. This is pretty much the first time it was ever written and proposed that we could actually, because now we had a little bit of memory. Remember when we started out, we didn't really have any memory. We read one line from the paper, executed that, advanced the paper, we forgot what we did 3 seconds ago. We're like a goldfish. So now we've got a little bit of memory. And this is the proposal that we could take those routines and pre-compile them and actually call them. The starts of the language and compiler is in this paper here. So the idea that we didn't have to reinvent the wheel, because code reuse didn't exist. I mean, if you didn't remember the instruction you executed 3 seconds ago, the closest you came to code reuse was looking in the log to remember which holes to punch the next 500 times you punched them. And so, of course, being our industry, this was incredibly well received, right? No. No, the same elitism we have today existed back then. It was, if you actually needed a compiled routine, you didn't belong in this business. If you didn't know which set of resistors and capacitors in a relay to line up, you didn't belong in this industry. How dare you? Thankfully, Grace kind of plugged away. Then in '94, she ended up with her own team and started building her own language. She actually had started it in '53 before the paper was published. But she went on and developed a language and was using it where she was working. And it was kind of lucky for us she did, because in 1959, the group started. In 1960, this document was published. The military, who had also, caused the Mark I to be built, realized that a couple of these languages had popped up, but there was no compatibility at all. No compatibility between any of these machines. And they were worried about vendor lock-in. So the phrase COBOL was actually their proposal. They were looking for something that they could declare as a standard and make multiple hardware vendors support, so they wouldn't be locked into a single hardware vendor. They created 3 committees, a short-term, intermediate, and long-term. And because she had written the paper, they pulled in Grace Hopper on the short-term. And of course, it's kind of like the government. So we're going to create a short-term to use for a year or two, an intermediate for 5 years out, knowing that we're going to throw it all away and do something else 10 years down the road. If you notice, that's the word COBOL on a tombstone there. Before Grace got pulled in, the effort was going so well on the short term that the people put in charge of it had already declared it was going to die a miserable death and failure. So Grace got involved, and because thankfully she had already been kind of building something, at her work and using it, what we call COBOL today is pretty much 95% what she had already built in the 1950s. And that was the short-term solution. And the intermediate and long-term never delivered anything, never happened. And thus we have now almost 60 years of COBOL. So, what was the environment COBOL was in? This is actually from a press release from 1959 for the IBM 7090, which was at the time the biggest, greatest thing in the world. It was IBM's first computer to be delivered that was entirely digital. It had no vacuum tubes in it, which was a big deal. Over 50,000 transistors. 5 billion transistors in the system on a chip for my Samsung S9. 50,000 was a big deal. 32,000 memory locations, 15-bit addressing, 36-bit word. We had not standardized yet on 8-bit bytes. I mean, it was just all over the place at that point, so we had to standardize. And they bragged about how much it could perform. I/O capacity, this was what could be hooked up to it. None of this came with it for that price. And the reason for the I/O is because you only had that many memory locations, you pretty much just did everything in batch, and you read from one tape and you wrote out to other tapes. And there's still shops that do that. They'll have multiple boxes. And one box will read in a data file and split it out to maybe 10 different tapes, and then you take those 10 tapes to 10 other boxes and run those 10 boxes in parallel. And that's how you got your multiprocessing in parallelism. But your cost there, $24 million in 2017 based on the Consumer Price Index. And you got 229,000 addition operations in a second. So, and so I just want to point out that with that amount of memory and because of the I/O and the way it worked, single responsibility principle kind of was born here. COBOL programs, you didn't have a lot of memory, so each program would do one thing. And do one thing and read its file in, do that one thing to it, write out the file, and then the next program would do the next thing. Some of the modernization work I've done, we've actually taken existing COBOL programs and basically changed them from reading from a file to acting more like a message queue. If you think about it as just a string of message queues, it lines up almost the same, except you're doing it straight in batch with only one program in memory at a time. And if you watched Hidden Figures, this is actually from the end of the movie. This is the new batch of recruits that are being brought in and being introduced. That is the IBM 7090 taking up the entire room. And some of these random stats about what can be performed in a second is the actual dialogue in that section of the movie. So the IBM 7090 is kind of the hidden star of the movie. But just, when COBOL was created as a standard, that was the degree of technology we had. It was really this bare bones and basic. Okay, and there it is. You've now seen COBOL. Ta-da! We're done. So no, this is Hello World. I mean, that's where we all start now, right? It's Hello World. So to kind of lay it out for you, there's kind of 4 zones within a COBOL line. And this also lines up with a punch card, if you've ever seen a punch card. A punch card is just like the paper tape. It's one row of punches per byte per character. So your first 6 are line numbers. The 7th one, this is a special column. The only thing I've ever seen it used for is to put an asterisk to indicate a comment. If you want a comment, it has to have an asterisk in that line. Advantage of this was you didn't have much processing power. So when you were reading in a program, you wanted to know as soon as possible, this is a comment line and I don't need to waste, I'm not even going to read the rest of that line. If I see that asterisk there, throw it. I don't need it. That's for you. That's not for me. The high-level sections have to start in one of the next 4 bytes. I've never seen anyone randomly space it, but technically they do not have to be left aligned on that line. They can start in any of those 4 positions. And then the rest of your program has to go after character 11. Now these spots over here, this is actually reserved because we realized that some of these programs started growing and 6 characters is no longer large enough for a line number. So now line numbers can actually go on the other side, and most COBOL code you see today is more like this with the line numbers on the other side. Now the advantage of the line numbers were most companies had sorters. So if you had a stack of 1,000 punch cards for your program and you dropped them, line numbers were your savior because the sorter could then put your program back into order so you didn't have to manually go through and go, wait, what went after my if statement? Because that was a thing. So COBOL program has 4 divisions: identification, environment, data, and working storage. Remember, we didn't have disk space back then. We had tape. You didn't have terminals to sit down and type. So how did the computer know what the program's name was? You didn't hit file open. So you needed to have a program ID at a minimum up there near the top. Author and date written are kind of nice for reference material. I don't think when they created the spec, I don't think they had any idea it was going to be around this long, but it's nice to have there. Environment kind of talks about what the environment is you're going to run in. These really aren't used that much anymore. I mean, they're there. They have random values in there. Our compilers don't seem to complain whatever random garbage you put in. Data division, this is where you define your variables. COBOL, you define all of your variables at the top, at the very top for your entire program. And procedure division is then where your code is. Now, the interesting thing about declaring your variables up here, there's a couple of reasons for that. One is while the compiler is running, or not necessarily when the compiler is running, because now we have it on disk, when you tell the workload manager you want to run a COBOL program, it can actually look and go down here. The environment division includes what files you need. So it can actually go and look and say, wait a minute, is this tape loaded or is this disk available? Because you have different classes of storage. If you're familiar with one of those big silos, your tape might be in there, it might not be in there. If it is in there, you might not have a drive available for it to go in right away. So workload manager can actually decide, I don't have all the resources for this yet. I'm going to put this job on pause for a second. And you also know how much storage you need for memory because you declare all of your storage up here, all your variables up here, so you know exactly how much memory your program is going to use. Whether it's going to process 1 row or 1,000,000, this is all the memory you're going to use for it. So it can make that educated decision of, I don't have enough RAM at this second, so I'm going to wait until something else finishes. Which, when you only had 32,000 bytes of RAM, was incredibly valuable. It's still nice today, because that's why most of our mainframe stuff never crashes. And so all of that is before we get down to our first line of code to say, oh, are we actually going to run this? The other thing is, notice it's all, except for my comment line. I messed up my comment line up there, but it's all in caps. The original COBOL spec was just caps. Most people keep it that way now for efficiency's sake. And this is a real-world example that I've actually been fighting for the last year. Montreal. How much processing overhead is there in matching a string to the word Montreal that's all uppercase versus mixed case versus the hell of Unicode? I can tell you that once you get down to actually trying to train your users that if they're searching for Montreal, there's 4 different variations on the E. This starts to double and triple your CPU utilization just to find your data if you're doing, especially if you're doing case insensitive. That's why most of your utility bills always show up with all caps, because this saves you money. It's just that much easier to handle. So let's talk a little bit about data types, since we've shown some code here. And just for, this is a, since Lewis had a nice picture he took, this is actually a picture I took of 4th of July fireworks one year. They look so much better from the Canadian side. Okay, and here it is. For those that were here earlier for the spoiler, when I wrote this talk, I assumed I was going to use our mainframe at work to do a couple of code samples that I'd throw into slides and everything would be good. And then the federal government shut down and I didn't have access to a system to do that testing over the holidays, to the Christmas break. So this is Micro Focus COBOL for Visual Studio. You can actually write COBOL that will compile to the .NET framework, or you can write native COBOL. They also support Eclipse, and I believe they will compile on the JVM, and it will run on Linux. Micro Focus loves making money convincing people to take their COBOL off of the mainframe, but keep it COBOL. So this is a community edition. It's actually available for a year license at the time for free.
Or a 2-year license.
Is it a 2-year license? I thought it was a year. But I had no intention of downloading this until I suddenly found myself unable to get to a system with COBOL on it to write some code. So the data types are pretty straightforward because this was a business-oriented language. So pick X, it means string, and it's a fixed width string because we want to know how many bytes of RAM we're going to use. So that is the number of bytes that we can have in that string. Side note that I've learned in the last year, on the mainframe, Unicode, that is still bytes, that is not characters. So the guidance is that if you think you're going to shove Unicode in there, to triple the number of characters you expect, because you just don't know. And if you're dealing with like a SQL Server and Oracle where you are defining a Unicode type with a number of characters, they're either masking that and allocating extra to have fixed width behind the scenes, or you're losing processing efficiency because it is a variable width field. If you've ever done performance comparisons of variable varchar versus char in database tables, especially if it's in an indexed field, I can tell you that I supported a system once that someone had built a primary key with a varchar that was going down every single day. I took a weekend, redesigned 3 tables, changed it to just fixed char, same width, and it went 7 months without going down. You have that much overhead of just not knowing how long your string is in advance. So you might waste a couple of bytes of space by doing that, but performance-wise, you can have incredible gains. So this is where COBOL gets interesting. So I've declared I'm going to have 100 bytes. Now I'm going to redefine that. And so name, city, state, balance, amount redefines balance, date of birth, this date of birth redefines that date of birth, then I've got notes. All of this is still in that same 100 bytes because I'm using redefines. So it's kind of, if you ever did C and you did something where you did a malloc and you grabbed your pointer and then you gave your pointer to a structure and then to a different structure depending on how you want to use it, it's the same concept. It's 100 bytes, but you can reference it 3 different ways if you want. So it's something you think of as being dangerous in C, but it's actually predates C by years. And where this comes in handy is in processing files. If you've ever seen a file spec for something where there's multiple types of records in a single file and you read like the first 2 bytes to figure out what record it is, one that I used to deal with quite a bit was the post office data. If you've ever subscribed to the post office address information system data for city, state, or address lookup, you will get sometimes 7 different layouts in a single fixed width file. And it's as simple as this. On the 5-digit, the input record is 95 bytes long. And the first record in the file will be a copyright record. And filler means, yes, the memory's there, but I really don't care, because let's face it, if it's a copyright record, who gives a... but if it's a detail record, then I want all of these individual fields to pull out. So I read the record. Oh, and I'll point out environment division. I've indicated that I'm going to have a file called 5-digit, and somewhere in the environment it's going to tell me where it is based on this alias here. On Windows, it's sitting in environment variable. On the mainframe, it's through job control language. So the file name isn't hard-coded, but I've defined an alias for it. And then here I've said my file definition is going to be this record layout. So the compiler knows at compile time the exact layout of the file I'm going to process. And so we get down to here, it's pretty much this straightforward. Read reads a line from a file. At the end, if I've hit the end of file, move Y to that status indicator. If not, then add 1 to this, just to count how many rows I've got. Evaluate is the equivalent of a switch or case statement. So evaluate, when it's C, yeah, copyright record, I don't really care. Display, kind of a printf. If it's D is a detail record in this case, then I'm going to call perform, which is calling another function, and I can specify my start label and my end label. Yes, in the early days, COBOL allowed goto. That hasn't really been in favor for decades. This is the more procedurally based syntax here. And all I'm doing right down there really is just a display. Now, the nice thing about this, from a performance standpoint, and I kind of hit upon it a little bit with talking about the file I/O and memory allocation, is this is the 5-digit record layout. You know, the copyright record versus the detail record. And this is kind of the sample data in the file. But when you call read, you're reading a fixed width row at a time. And because I've defined that record length, when I call read, it's not looking for an end of line character. It's just simply grabbing 95 bytes and dropping it into that already allocated memory. If you've ever done Java or .NET and watched your resource allocation, if you're allocating strings inside of a loop and seen it, you know, you're allocating 20 character strings, but you've used up 7 gigs of RAM before garbage collection happened, it doesn't happen here. I define 95 bytes once, and that's all I ever need. So, you know, reading CSV, XML, JSON, incredibly more CPU intensive. For me personally, the Montreal example came because somebody decided that instead of supplying us our nice fixed width file we've used for the last 4 decades, they were going to go to XML. And just the reading the file in and splitting it apart to jam it into a database takes over twice as much CPU in XML as it does a flat file. Just because of the overhead pretty much of finding the end of a line and then. So this here, let me go back to full screen on this so you can see that a little bit better. This is the open source C# implementation of readline from the string reader class. If you notice, there's ifs, there's allocate a string builder, there's nested do while loops, checking for, I love the comments, oh shoot, are we on Unix, are we on DOS, are we on a Mac, which end of return, which end of line character are we looking for? And then even though we allocated a string builder up here, now we're actually doing a toString down here, and then you've got your marshalling from the readline method within the stream reader class to the string variable in your, wherever you called it from. That versus give me 95 bytes of memory, drop it there. There's that much overhead in just reading a line of data the way, and this is just for CSV. Now imagine you're in a complex XML or JSON where end of line just tells you might have reached the end of the current element tag. And if you've got an XML file with 800, 700 elements in it, and it's in each record, and some of them repeat, this becomes a nightmare. So we also cheat a little bit on the mainframe. The operating system is actually optimized to help us out. So this is JCL for creating a file name that has the alias AIS 5-digit. This is actually what the program would get. but I've defined it as LRECL95 and given it a block size. So the operating system actually has metadata that knows how long each record is going to be in that file. So the operating system actually queues up the file in an optimized order to help the program. And the block size is always going to be a multiple of LRECL, the logical record length, so that the buffering actually falls nicely in line with that. It's why mainframes continue to process the data files they do, is everything is optimized around processing data. If you think about NTFS, ext4 on Linux, what are those file systems optimized for? Playing your DVD. It's definitely not, optimized to this level for doing data. So other constructs, I've kind of already shown off the redefines. Go back to duplicate here. And just for grins, I wanted to show a little bit of math. So so what could I write that actually used math? And so FizzBuzz, I mean, it's right there next to Hello World, right? So COBOL was intended to be like English. So if you notice, I didn't name this one, but these are called paragraphs. Paragraphs are in sections. Statements end with periods because we're trying to look like English, which is why we're so verbose. Divide by giving plus the remainder. So it's doing the div and the mod at the same time, but you're getting very verbose with your syntax. And this one here, if I actually do F5, I've got my breakpoint set. And there it is, actually COBOL running in Visual Studio on Windows. It honestly works. So this is kind of perform, it's a call, but it's also a for loop. So I can say I'm going to perform from 1000 FizzBuzz through 1000 exit, varying loop count from 1 by 1 until loop count is greater than 100. So kind of combine your call and your for loop all in one. Again, yeah, very, very verbose, but the idea was to make it user-friendly as far as being readable. I'm not really a COBOL programmer myself. I end up just reading a lot of it and giving direction on where to go with it, but it's not that hard of a language to pick up just because of, I say it's the brilliance of actually making it readable as opposed to K&R coming along with C and figuring out how many obscure symbols you can put in a row and make it compile. Quite ironic for as expensive as disk space was back then that they created something verbose for a reason, that it would be useful. Let's see. Oh, no. So this one here, this is actually one of the Micro Focus samples they built in. You can embed SQL. You declare this here is kind of like include files in C. You can include, you can do includes and copies, copybooks. The difference is the text from the other file goes exactly where the statement is. So it's not like an include at the top. No, this says include book right here. It is literally going to go find the file name book and insert it between those two statements. So it does allow for code reuse in a couple of different ways. We have a common error handling routine that has one copybook we include up there in the top in the working storage section in the variables. That's common variables we need for our error handling routine. And then we numbered it starting with the 9,000 paragraph. So the very last line of every program is a copy to include the actual code for our error handling routine. And then every program we have says, oh, we have an exception, we have a problem. I call the 9,000 paragraph, or I move a couple of values first to the fields that I know are going to be there, and then I call the 9,000 paragraph. It's in 600 programs, and we've only typed it in once, and if we need to make a change, we only have to change it in one file. not as nice as object-oriented where I can just drop a new DLL. I do have to recompile everything, but for 1960 technology, it works pretty slick. So for here with the cursor, declared the cursor for select, which means that I'm going to return it. And so I just, I can fetch into a loop. I can build a loop around my fetch. I open a cursor, close cursor. If you've ever done embedded SQL, T-SQL, PL-SQL, it's all kind of similar. Let's see, I do not have a linkage section on that one. We go to this one, I've got a linkage section. So linkage section allows you to pass in parameters. So this one, I'm using a copybook called State Verified. So let me bring that up real quick. Where did it go? Actually, that's wrong. It should actually be city-state. I'm not sure why I goofed up and renamed it. So this is my copybook, which just simply defines a record layout. I can include that in any program that would need to call the routine and instantly have the format that the routine needs. So if I go back over here, so I've got linkage section, which says I'm going to get that fields in, and then I add this little clause here using ls parameters. And that's enough to tell the compiler that I'm going to be calling this from another program. And at that point, it's just like those variables had been declared in that program. Where this gets interesting, so I've been talking about COBOL. If I have a linkage section, like I said, I can call this. It's almost like a callable procedure that I can call from somewhere else. I change two compiler options. This is a DB2 stored procedure, and I can call from anywhere in the world that I can get an ODBC or JDBC, ADODB, anything that I can make a database call, I can now reuse this code from any other platform and get sub-second performance. We did this with a lot of COBOL code where my very first project was actually building a .NET web front end to get rid of their old green screen. And we ended up leveraging like 2 million lines of COBOL code, turning it into stored procedures that we could call. And if you looked at the front end code, you see, oh, I don't know what database they're using, but they're just calling stored procedures and they're getting cursors back and declare a data set, do a data adapter.fill, boom, I'm off with a bunch of data and running. It works awesome. Other interesting features that we're on an IBM mainframe, they're the big one still. If I've got a linkage section like this, I can actually turn this into a message queue. I can set up a message queue and say every time a message comes in, pass the message to this program. And it can then write it out to another message queue. Craziest one, I can actually turn this into a web service or a RESTful service. They actually have a plugin for their CICS, or which we commonly call KICS, transaction server that would make this code available as a web service. Hosted on HTTP, you wouldn't have to know that it was actually sitting on a mainframe. So we are leveraging, 30, 40-year-old code in some cases, and making it look to the, casual observer like it was new code that was written. But like I said, we reused 2 million lines of code on one project that goes back 30, 40 years in some cases. So there is full SQL support. It's hideous syntax. That's where I think they went wrong. They're trying to stay up with the times. There is native XML support built into COBOL now. It's hideous looking, almost as bad as the object-oriented support. Someone decided that because object-oriented was a fad, they had to make object-oriented COBOL, and it's just wrong. That's wrong. That's where they jumped the shark. They need to go back in their lane. So kind of, food for thought here. Define legacy. So how many of you have written code that's still running after 10 years? That isn't COBOL or on a mainframe? 15 years. That would eliminate anyone who's ever coded for Mac because Apple just threw out your entire architecture on you. 20 years. I've got my very first .NET program that I wrote in beta is getting close to 20 years old now and is still out there. It scared the hell out of me when someone called me last year and asked if I was available to support it. So in Java, going from 1.4 to 1.6 broke a lot of stuff in the 2000s. So we have code that's 30, 40 years old that is still running on the most modern, newest hardware with full vendor support with very little maintenance or modifications to it. So I kind of, just kind of want to change your perspective a little bit. How do you define legacy if you're talking about something that is still fully supported and still performs incredibly well? And if you give IBM enough money, you pick up the phone and they will jump on a plane and fly to you on same-day notice. Which Microsoft will too if you throw enough money at them. It's kind of fun to have that much money you're wasting on support.
It's a lot more money though.
Yeah. Yeah, but when your system dies on tax day, it's amazing how little money matters when you're telling IBM to get their ass on a plane.
Take the example, my dad was an engineer on mainframes years ago, and at that time we lived in Ireland. Got a phone call one day saying, "Going to get on a plane to Nigeria to go fix a computer for me." They'll pick anybody up and just send them halfway across the world to fix a problem. They were really good at it.
Yeah. Yeah, no, and funny thing for us is we had the embarrassment last year with tax day. And 2 years before that, we had a little bit of embarrassment in February, March timeframe that didn't cause as much headache. Both of those failures were not actually with the mainframe itself, but with the disk substorage subsystem, because we use modern storage area networks, just like all the tier 2 shops do. And both of those failures were in disk subsystems that were less than 18 months old. And when an entire rack just dies on you, not much you can do. Yeah?
I've got a piece of Fortran that's running Pontiac at powertrain since 19.
Yeah, so some of this is some of the stuff I do has been kind of fun because you've got initials in there of who worked on it at different times in the comments, and some of the comments are so old that you can't even figure out who it might have been that worked on it. But I've been there for 15 years and there's comments in there of people that I've never met. So just trying to change the perspective of what do we call legacy, and maybe there's some lessons to be learned from this older technology. I mean, they spent 30, 40 years kind of, working out some of these bugs, and we basically just threw all that knowledge away and started over. We wouldn't do the same thing in architecture. We wouldn't say, what did those Romans know? We don't need an arch. Let's figure out something else. So that's pretty much the end of the talk. How did I do on time? Wow, I actually didn't. I ran through it too fast today. Yeah.
Yeah, there's one thing about IBM 360 and beyond mainframes is in the Intel processor world, you have hacker programs that come in and screw around and do all sorts of stuff. On the mainframe, addressing is base plus displacement. The program only knows the displacement. The operating system assigns the base, so that there's no way that a program could go to another program because it doesn't know the base.
Windows does that now with randomization as well. They actually randomize it. So in Windows now, it used to be that you could look in the memory and find a DLL in a particular location, but now it has randomized relocation of DLLs, so you can't even do it even from one run to the next. It's different.
But it's kind of interesting. You could say, all right, my program is this big, but the real address is up here because the operating system assigned this base, and you have the displacement. And then once there's a certain point at which that's as much as your program gets, and because some other base is going above that. So you are basically boxed into your program area in terms of what you can address. So you could be a hacker, and all you're going to be doing is hacking yourself.
I've got another example for you where those copybooks come in really useful. So I worked for a company that did RPG and COBOL translations in Europe, and we would get American packages come in with American date formats, and all we'd have to do is plug in a different copybook and reformat the date to work with European dates.
Right. And I guess just you know, a common use we have for the copybooks, just to make it obvious, we have one team that builds copybooks for all of the tax forms. There's one team that's every single format involved with the tax form, the file formats, everything is done by one team. And then the 10,000 plus programs that are involved in the tax system don't worry about the file formats themselves. They know that as long as the variable names were kept the same, they don't have to care at all about the actual size of the file or anything changing, because they just reference the copybook. So there's just one team over there that just takes care of, we call them the core record layouts. And when they announce one day, okay, core record layouts are ready, everyone can just start recompiling their programs in development and test them for whatever the next set of tax changes are. Yeah?
I have two questions. So first, why is GoTo not a bad invention?
So in the early days, and before they came up with the idea of the structured programming, they were doing GoTos, but GoTos didn't necessarily know where to return to. So you would say, if I got this condition, go to line 500, but when you went to line 500 and you got maybe you're 10 lines down, that line of code actually had a need to know where to jump to next. So you ended up with really ugly spaghetti code that you couldn't necessarily read clearly.
You also have to know where you came from.
Yeah, I'm sorry. Yeah, you had to know where you came from and how to get to where you should go back to. So that's kind of the perform specifying through was just a huge leap forward from the tangled code before.
It saves forests. We used to have to print out the programs and draw on them the lines from where it jumped to where it would go on the rollout fan paper, and then work out where it came back to, because otherwise you got completely lost. And if you had a bug in that, the guy that wrote it maybe left the bug behind, you were royally.
Yeah, in the newer tools, IBM offers a COBOL environment for mainframe programmers that's based on Eclipse, and it will actually draw out your call stacks for you, and draw all the system diagrams for you, so you don't have to flowchart. And just drop it in a window on the bottom of your screen there, and you just go, oh, I need to figure out how to get to paragraph 3000. Oh, it's called right here. Okay, yeah.
And
So much
COBOL
easier.
has paragraphs. RPG doesn't.
So I personally wouldn't want to program in it every day, but COBOL is far from the worst language I deal with. JavaScript, Java, put those two together, yes.
Isn't that what JavaScript is? It's Java with scripting.
And actually, I hate JavaScript less than I hate Java, which I volunteer 2 mornings a week teaching Java to high school kids. Which, if anyone's interested, actually they are recruiting volunteers for next school year. Southeast, I believe it's Southeast Michigan right now, there are 45 high schools that are looking to join the program and develop an AP computer science program. So I'm part of a group called TEALS. They find computer programmers that are willing to volunteer to spend a couple of days a week in a class. It's AP Computer. The one I'm in is AP Computer Science A, basically first semester college Java. And it's just kind of going in there and helping the high school teacher. There's an actual high school teacher in the room. And it's basically helping them learn the curriculum and backing them up to get through the first year of the class until they build that knowledge and strength to be able to teach the class themselves. I got kind of lucky. I've actually got my teacher is a former programmer who decided he'd had enough of Chrysler, retired, and then decided to become a teacher at his alma mater for his last couple of years of life. So he never taught Java, but he actually already knew programming, so he didn't have to learn the for loop and an if statement and all that stuff. But it's pretty rewarding, despite the fact that it is Java. It's Java. It looks enough like C# that I only get thrown off every once in a while. It is really bad though when the teacher's writing something on the board, because he's an old school teacher, so he writes everything on the whiteboard instead of projector. And he'll start to write out something like, wait a minute, can I do this with an array list? And I'm like, God, I hope Java won't let you do that. I think that's just array. No, array list, no, don't. If it does let them do it, don't teach them that. No. let's fix it now. Don't even mention that. But no, they have a full curriculum built for every single day of the school year, so it's not like you're actually out creating your own curriculum. They actually hand you this gigantic PDF file that basically says day one start here, and it actually has every single lesson plan you need. So if you're interested, I can give you the info to sign up afterwards.
And you said it's only Java, or are there other schools that do other languages?
The part I'm in is only Java. There's a computer principles that's doing some kind of GUI tool that's kind of leading them into programming, but isn't really a programming language. But it's based on what the College Board test, because it's what education has been boiled down to at this point. It's AP Computer Science A, so it's a curriculum that is been blessed by the College Board and is geared towards helping the kids pass the AP Computer Science A test, which I think is offered in Java and maybe PHP. There might have been a PHP version.
The thing about Java is the compiler or whatever you need to be gotten for free, I think.
Be careful. Oracle's trying to charge people for using that word now. That was a long conference call today. It was on Oracle and.
Oh, are you having to deal with that too?
Oh yeah.
Yeah.
Yep, and we have code that won't run on OpenJDK because it uses stuff.
They're kind of just like, why can't we just bundle it anyway and make them pay? And it's like, lawyers is why.
Yeah.
Now,
Well.
so my second question is, you said that now almost supports SQL and other things like object-oriented programming.
Mm-hmm.
So you have a mainframe, let's say.
Mm-hmm.
How is this language change supported? So today we get version 4.7 of .NET or whatever, .NET Core. Back in the day, back in the mid-80s, you'd have a Windows program running on a DOS machine, you would go and check. So how do you that sort of thing? So how do you know that, first off, what is your code version?
Mm-hmm.
B, how does the mainframe get updated?
So,
like SQL and other features.
Okay, all right. Good question. There's multiple parts to that. So the COBOL is a specification. What most people work off of is COBOL 85. What was finalized in 85, that's when SQL was added. The big one before that was 77. In 85 really was pretty much SQL was added. XML was added in 2002, I think. Object-oriented was somewhere in between there, but it's usually the year that the spec was updated. So IBM ships updates. I mean, I'm assuming they show up on a big tape. I worked in the AS400 shop back in the day when we got an 11-inch floppy, and you'd shove an 11-inch floppy in and walk over and hit a button, and it would do your patching. Or you get a tape. You'd get a tape that was about that big, and might have held 40 megs on it. But no, I mean, IBM ships updates. We're on COS version 2 dot something. They changed the naming. It used to be OS 360, and they got up to some high number, and then they reset when they changed it to the ZOS operating system. But no, it's just another collection of software, and they ship regular updates, regular PTFs. You go through patching cycles on. Hardware, they're currently on what they call the Z14 chip, which is, I believe, the only commercially available processor out there that can hit 5 gigahertz for consistently. You get, I'm trying to think how many come in a drawer now. They've changed the terminology. We used to have books, And a book had 12 processors on a board. 2 were the equivalent of like your North Bridge, South Bridge, that just did, making sure the memory got back, got changed out and stuff like that. And of the other 10, 8 of them were licensable, and 2 of them were backup spares. So if you had a processor failed, one of the spares on board would actually take over, which is just part of the redundant, keeping them up. Yeah, you do kind of pay twice, but it's capacity. You can do capacity on demand, but you buy the physical board that has all the chips on it, and then you buy a license key to turn on the amount of capacity you want. We're about to upgrade to the Z14s ourselves, but they're like refrigerator-sized boxes, and because all the storage is external, it's kind of another kind of thing that we kind of relearned. Storage area network. If you look at the old pictures of the mainframes, because they originally existed before we had disk storage, it's always been a storage area network. Storage was never inside the box like we were used to in the PC world. I know the first time I saw servers and desktops being pitched was diskless stations where you had a hard drive on the other side of the room that you booted off of. It seemed kind of foreign for client server, but the mainframe's always been that way. So a mainframe upgrade is actually unplugging all your fiber cables for your disk subsystem and plugging them into the new box. And then you go into a little bit of config and turn it on, and it actually boots off the existing disk. And maybe you install a couple updated drivers, but we do entire $15 million hardware upgrades over the weekend and no one notices. We kind of switch over to our failover site. We're down to 2 computing centers now. We used to have 3. But the mainframes kept getting smaller, so we only need 2 now. But we switch processing over to the alternate site in another state. They wheel in, wheel in the mainframe the week before. They make sure it boots up. It's water cooled. Make sure that everything is going to turn on, and then. Yeah. And then you just kind of say, okay, turn this one off. Turn this one on, it's the primary, and you update your DNS or IP address settings, and you're good to go. Otherwise, there's actually, IBM has gotten to the point they don't like the word mainframe anymore. It's enterprise server. Enterprise server. Because dirty little secret of the mainframe world, when they actually made it so it supported Ethernet, all of the networking code is actually running on Unix anyways. So mainframe's been running Unix since 1980s. And now, the craziest damn thing ever, you can get a copy of Red Hat Enterprise Linux that runs on the Z architecture, and Oracle will sell you a database that will run on that Red Hat instance on your enterprise server. And because of the 80,000 I/O channels, it performs really well. It seems like the weirdest thing ever, but might have something to do with why IBM went out and bought Red Hat. Is Red Hat Linux runs really, really well on a 5 gigahertz custom processor with lots of fiber channel connections. It's some things it's not good at, but it is really good at that. And since it does run Unix and can run Linux, it runs Java. I hate to say it. I've been afraid to ask. I want to ask them because Red Hat was also involved in helping Microsoft with getting .NET Core to run on Linux. Red Hat was a big partner of Microsoft in the .NET Core world. And I'm just afraid to ask because I'm afraid they're going to tell me yes, it would work, but I think .NET Core might actually run on a Linux partition running on the mainframe. So it's a crazy world. It really is. It's just kind of wild that you can just split it off and say, you know what, I'm going to create 3 virtual processors out of this box and dedicate them to this virtual machine that's going to run Red Hat and go do its thing. And at the hypervisor level, it's a mainframe, but to anyone else looking at it, it's a Linux box running WebSphere or Firefly or whatever your web app server of choice is. And yeah.
When I used to work for NBD on our mainframes, we were running IBM OS2. Do they still run that, or is that long gone?
That's long gone. That's part of the renaming stuff, is they tried separating themselves from any of the original OS/thing. So now it's Z/OS.
It's what slash?
Z/OS. IBM went through a complete rebranding thing a few years ago, where if it's the enterprise server, it starts with a Z. AS400s are I. The Power Series is P, which I don't know, is anyone still using Power Series?
Is anyone ever using it?
IBM did, I don't know. I think that's what Watson was originally built on. But yeah, so they did a rebranding where they got rid of all the old names so they could seem more hip. But
yeah, I can understand that, but you're not sure what the new names equal to the old names.
if you're giving IBM enough money for support, they gave you a translation table.
Okay.
So, which, you know, with IBM, that's what it's about, is how much money are you giving them for support. That is probably the one downside of COBOL. Granted, this one here is, Micro Focus is available in a community edition that works with Visual Studio or with Eclipse as a free community edition version. Otherwise, finding COBOL compilers could be pretty expensive. Actually, Dustin and I had joked about setting up a half-day workshop at Code Mash and actually teaching COBOL. And the problem,
we're doing our workshop.
we're going to do our workshop. We're going to do it.
We gotta get a mainframe one.
Yeah.
Upgraded from IBM.
Getting an IBM virtual environment that will run on your desktop that looks like a mainframe is $5,000 a workstation per year.
You wanna, Brian is graciously volunteer
I was gonna say,
sponsor.
considering where I work, I might be able to just have a VM haul out of my laptop for y'all for a day. You know where I work now, right?
No.
I'll pay later.
Okay. Oh, I feel sorry for you.
Sadly.
Yeah, no. It's almost as bad as, yeah.
What's wrong with computer? Yeah, I work. I still work.
So it's kind of scary because I actually didn't realize there was anything left called CompuWare.
Oh, we have Compuware Holdings, Compuware, Dynatrace, something like that.
My original employer actually was friends with Pete before he started CompuWare. And when Pete started CompuWare and was successful, then Andy went off and started the consulting firm I started with. And so I had never met Pete, and I didn't even know his last name. I just heard all these stories about Pete. And when we got into legal trouble with Ford and tried suing them, and they countersued and all that stuff, and that's why I ended up with the government. Pete offered to buy the company, but Andy got offended that Pete didn't offer him enough money, and so instead we went bankrupt. And 10 years later, Ford was forced to pay him up, but a little bit late for the company. No, CompuWare had some good tools. I actually used a couple of their tools back in the day.
CompuWare had some amazing stuff. And on the mainframe, IBM, with their operating system, had a sort utility, but CompuWare had one that would run circles around it with inefficiency and stuff like that.
Avendate, FileAid.
It was called SyncSort.
Yeah, that's right.
We actually used to use all of those tools.
Yeah, they were on every IBM mainframe on the planet.
Yep.
So IBM finally decided that they were gonna, quote unquote, make their own.
And the other ones are still on every mainframe on the planet because the IBM ones are really good.
And that's why, well.
I'm not allowed to say that because I don't have a choice.
Okay, what do we got for swag? Oh.
Thanks, man.
Oh, yeah.